Well, that's it, folks. It's all over. The end is nigh. It has arrived, and we'll tell all of you all about it today here at the Smash News Network, least busted name in news. It's all over, folks. This is it. Here's the past 24 hours from SDO in 304 angstroms. Earth scale there, just behind a huge sunspot group and massive plasma filaments. Sunlight. It's all about to change, fundamentally. Here's the full disk view in the same wavelength. And we figure we might as well show you the last 24 hours here before it's all over. Here's the equatorial zoom in SDO 304 angstroms wavelength. That's ionized helium, by the way. And I've got to stop doing the voice because I want it to hold out for the rest of the video. Huge plasma filaments there. You can see some filaments in the northeast, in the northwest. Also a huge plasma filament in the southwest. This one in the northwest, by the way, is on its way out right now. It is currently in the process of becoming a coronal mass ejection. We'll tell you later in the video if it is likely to be earthly directed. Also, as predicted, as forecast, we've got a solar polar vortex happening in the south polar region. You can see the Cornell West filament there going berserk, becoming very unstable and starting to swirl around the south heliographic pole. How you like that footage? Pretty sweet, right? Also a huge plasma filament up there in the northeast. Fantastic imagery there from SDO, the Solar Dynamics Observatory. Very high likelihood of major solar flares, coronal mass ejections, and more space weather. We'll talk all about it on today's Daily Space Weather, which is back to our original format, and we won't bother you with the minutia of why that is. Instead, here's yesterday plus today from the SDO. Once again, this is the SDO continuum. And a little bit of growth with this sunspot. As you can see, some sudden umbral migrations happening there. Umbral migrations happening down here. We've got quite a high likelihood of large solar flares, especially down here in the southwestern limb. See those sunspot groups about to set? Don't be surprised to see them produce an X-class flare in the coming 24 to 48 hours. There's your colorized magnetogram for yesterday plus today. Quite a bit of magnetic shear associated with this sunspot that's just moving past the Earth strike zone. And let's briefly see what's going on at Croissant Earth. Yes, Croissant Earth. Sounds like there's an echo in here. Let's see what volcanoes are erupting. Mount Mayon continues to erupt. Now it's producing a 9,000-foot plume of volcanic ash. It's a flight level 090. Flight level 120 over Krakatoa. So big uptick there at Krakatoa. 12,000-foot ash plume over the Sunda Strait. Semeru exploding. Flight level 140 over East Java, Indonesia. Kilauea continues its effusive eruption. The lava supply from the southwest cinder cone and the crater wall of the southwestern lava lake has ceased, or at least decreased, at about 1600 local time this afternoon. Up to this change, the vent activity had been mainly vigorous. So a little downtick there at Kilauea, it looks like. The volcanic seismic tremor started to decrease at about 1600 local time this afternoon as well. Popocatépetl exploding in central Mexico, it looks like. No indication on a volcanic ash plume size. Just take it as a reminder to not fly your hang glider over Popocatépetl. Fuego exploding, flight level 150 in Guatemala. Nevado de Ruiz exploding. 3,600-foot ash plume there, flight level 036. Sangay in Ecuador has dispersed its volcanic ash. Revenador exploding, flight level 150, 15,000-foot ash plume and 22,000-foot ash plume over Sabancaya. Before we get to earthquakes, briefly take a moment to visit our links. One of the links you'll find below the video is the link to our Redbubble shop. You can also find it on our homepage at smashomash.com under the Smasho merch header. Today's featured product is Universum Liberate, because if I could wave my magic wand, I'd set everybody free. Yeah, each and every one of you. Every one of you who is enslaved by various things, I'd set you free if I could help it. If that's too reckless, I don't really care. Universum Liberate is the message of this thing, and if that looks like a military insignia unit patch type of a thing, well, that's exactly what it is. The Galactic Federation Special Forces is a military unit, and if you would like to show your support for bringing peace to the galaxy, then pick up some of the Universum Liberate products. You can also convince your friends and foes that you're in the Illuminati. That should be fun, as they're probably, well, who knows? Who knows how many of your friends have been convinced of utter nonsense from the internet? However, the Galactic Federation Special Forces are no joke. The symbolism represents the Milky Way galaxy itself, signal strength, security, and integrity, and also instantaneous galactic scale reach. Pardon my transparency. This is what happens when the end is here. You can also find links to our Hemp Lucid shop below the video and on the homepage. If you're shopping at hemplucid.com, don't forget to enter the promo code SMASHOMASH. Wouldn't you like to save 10% on your order? I mean, saving some cash, we're all about it, right? Various different ways we provide some additional value-added services for our clients. People like you viewing the videos are our clients, not just the Smash team. So check out the products at hemplucid.com. Enter the promo code SMASHOMASH to save your 10% on your order. Try the CBD lip balms if you haven't. I use them. I also like the Focus Mushroom Gummies, so try those out if you haven't. Links below the video and on the homepage. Today's featured product on the Amazon shop is our radiation reflecting hat, our chrome radiation reflecting hat. Today's featured product. And why? Because, well, if you're in your bunker, you got to have a radiation reflecting hat, and that's why we're featuring it. Yeah. Amazon.com/shop/Smashomash will find you our idea lists, so check those out if you haven't. And let's see what's going on seismically. There's the past 90 days. We've got moderate levels of seismic activity according to volcanodiscovery.com. And let's see what's been shaken over the past 24. Papua New Guinea had a 5.9. That must be one of the largest quakes. That was at about 11:18 Universal Time yesterday. Indonesia had a 5.2. That was at 21:16 Universal Time yesterday evening. Papua New Guinea had a 5.2 at 22:40 yesterday evening. Tonga had a 5.2 also. That was at 3:45 this morning. Pretty seismically calm here, overall speaking, for the past 24. Last but not least, as far as our 5s and larger quakes, 5.5 also struck Indonesia here at 8:39 this morning. And let's get back to space, since we've got some more fresh footage for you. Here is the last 24 in SDO 171 angstroms. So there's the house favorite wavelength. Massive amounts of filamentary activity here. A crazy number of sunspots as forecasted a few days ago. Now pushing 200 for the sunspot number. If you thought we were in a grand solar minimum, you should think again and maybe look at reality. Or if you prefer to stay in your cult, by all means, enjoy your cult. I'm sure it's very fulfilling to be around other people that believe utter nonsense. Here we've added 211 angstroms, and let's talk about some stats. 10.7 centimeter radial flux is now at 169. Solar flux units 169 is the 10 points, the F107 as it's sometimes called. And the radial flux is very proportional to sunspot number. You can see the comparison in this chart right here. It shows the black line there is the 10.7 and the red line is the sunspot number. You can see each peak and trough are generally consistent with each other, although recently the sunspot number has surpassed the radial flux. So you can expect the radial flux to continue to uptick here. Sunspot number will also uptick. I believe we've got a couple of new groups that don't have names yet. We'll get to it. First, a space weather enthusiast dashboard here showing us no forecasts for space weather, and I would tend to agree. I don't think there's anything else on the way. It's smooth sailing between Earth and Sun at the moment. By the way, our forecasts for CME impacts yesterday could not have possibly been more accurate. We'll get to that also. First, the last 4 hours of Earth's magnetic moment from space. So we are seeing some gyrations in the solar wind here, which is why you see those perturbations happening there. That is variations in the solar wind speed, I think. We'll cover that in a moment as well. That's the past 4 hours of Earth's magnetic moment from space. It is a geomagnetically calm situation. Earth's magnetic moment from the ground depicted here. Also the last 4 hours. This will show you the most likely places to see the aurora. Also the most likely places to see telluric currents, causing things like induction into power grids, pipelines, and railways. That's our ground magnetic perturbations map depicting nanotesla magnetic flux density at Earth's surface. Next, the planetary K index is currently at 1.66, KP 1.66, 1.6, which is rounded to 1.67, by the way, if you're not a math nerd. Planetary K index is an average of global geomagnetism. So looking at the real-time solar wind, and here are the CMEs that we forecasted. So right here, the real-time solar wind switched from the ACE to the Discover. Right there, you can see that signal. That is the baseline, and right there is a little CME impact. And right here is a second little glancing blow CME impact, exactly as forecasted, and on the exact day that we forecasted it, on the 19th. So showing up just on time there, early in the day on the 20th and midday on the 19th. Two little glancing blow CME impacts there, coronal mass ejections. They were minor. Current conditions are, we could be getting into geomagnetic unrest situation here, actually. We've got a solar wind of 450 kilometers a second, solar wind density of 8.1, and then we've got a BT of 8 nanotesla and a BZ of -5. So if that keeps up with an 8 nanotesla for the total field and -5 for the BZ, the vertical component of that magnetic field, that could push us right into geomagnetic unrest or even minor geomagnetic storm conditions. So I don't suspect that will happen, as that field has been shifty. We're expecting it to stay shifty. We aren't expecting this to turn into a geomagnetic storm. But if we do get a strong negative BZ signal, which looks like it's already subsiding, then that could happen. Again, current conditions are about 450 kilometers a second for the solar wind speed. Solar wind density just under 9 protons per cubic centimeter. GOES magnetometers here looking pretty smooth over the past 24. Again, those were just glancing blow CME impacts exactly as we forecasted. And let's take a look at the heliospheric current sheet. So there is a North Pole current sheet headed this way, and it looks like there's a delay, an indication we could see more sunspots in the northeast. Also, we're keeping a close eye on this North Pole-oriented magnetism, because that's got to leave the North Heliographic Pole. The sun is about to kick into overdrive, folks. We are not yet at solar maximum. I don't care who's been telling you we're at solar maximum. That's just... Nobody who doesn't have their head completely up there, you-know-what, is stating that we're at solar maximum. Only clueless people who are attempting to pivot and gaslight their viewers are claiming that we are at solar maximum. If you're in a cult, feel free to leave, although feel free to stay. We encourage you to be in whatever cult you like. If you'd like to believe nonsense, by all means, have at it. Here's our line of sight field plot. It depicts the gong magnetogram here in grayscale. solar B field in blue, north and south solar polar fields in green and red respectively, which brings us to coronal holes. We've got some North Pole oriented coronal holes rotating down here in the southeast. Let's take a look at that by subtracting the 171 angstroms wavelength from this spectacular 24-hour video from SDO. So there's 171 plus 211, and there's 211 angstroms by itself. A different species of ionized iron that's great at highlighting coronal holes. You can expect these North Pole-oriented coronal holes down here to become more well-defined in the coming days. There is a sector boundary crossing there, probably. It is still a few days off before getting to Earth. These coronal holes, these are all North Pole coronal holes. That brings us to sunspots. And here's what's going on. Do we have any new groups? So yeah, there's a group out here in the northwest that doesn't have a name yet. That ought to get a name. So there's at least one group that's not named. Make it two. At least two new sunspot groups. So yeah, pushing 200 sunspots. Just some more facts there. And if you think 200 sunspots is solar maximum, maybe. But a lot of people who know what they're talking about are forecasting a little bit higher levels than 200 for the peak of this solar cycle. Anyway, here's the past 24 hours. Now we've got 171 plus the SDO continuum there. To highlight the active regions, it shows a lot of life around those sunspots. The AIA instrument and the HMI instrument there at the same time, depicting both the photosphere and the lower solar corona is what is depicted by the 171 angstroms. So let's subtract that wavelength. Here is just the HMI continuum. And that is approximately 200 sunspots. So that is a very active sun, hundreds of sunspots there in plain view. A very high likelihood of large solar flares. Massive number of umbrae there. And huge plasma loops there of connected magnetic fields and interacting, canceling magnetic fields and all kinds of violent stuff happening right there in the Earth-facing portion of the solar disk. It's a good time to be doing space weather. Anyway, next we'll cover energetic particles and solar flares. So, starting out with the ghost proton flux, no spikes, and flaring has been minor here. So, once again, we've got some underperforming sunspots here. The likelihood of major solar flares, as shown in the solar flare probability, very, very high. Some flares there, some 30% probabilities there showing up for X-class flares. So, but as far as relativistic particles, no solar energetic particle events. And once again, flaring happening as we produce the video. So there's a flare in the process of happening now. Let's see if it's leveled out yet. Looks like it has not yet reached peak flux. And we did have one M-class flare in the past 24 hours, two in the past 36. So 2 M-class flares. And let's get to some flare wavelengths. There is 171 plus 131 angstroms. We'll also show 94 plus 171 from SDO. And let's subtract the 171 and show just 94 angstroms. So we've got significant flare players here. My favorite spot for a large solar flare, believe it or not, is down here. That's my first large flare location. The most likely spot for an X-class flare, in my opinion. Next would be actually this group, which is right in the Earth-facing zone, followed by this group, and finally this group up here. So we've got 4 significant flare players there. Those are the most likely places for big solar flares. And let's talk more about why the end is near. Yeah, the end. It's all over, folks. It's all over, folks. We're done. We're toast. So here's what's going on overhead Lehigh Valley. We've got cloudy skies, and we've got Mercury up there, also Saturn and Jupiter. The best time to view planets, in my opinion, is right after dusk. This is what it'll be like after dusk. You'll have You'll have a sliver moon, Venus and Mars up there by the ecliptic. So a great time to view the sky here after dusk. Next, your solar system forecast. This is where things are now. And let's advance this to where things will be in 1 week. We will have a gibbous waxing moon by the 27th of June. And here's what I'm talking about when I say it's all over. Spring, it's all over. Or perhaps autumn is all over if you're in the southern hemisphere. You've only got 1 day, 3 hours, and 49 minutes from the time I made this video. If you want your own countdown timer, join us at timeanddate.com, timeanddate.com for your solstice countdown timer. By the way, we will be streaming here at the Smash News Network, Least Busted Name in News. We will be streaming at the moment of the solstice tomorrow. So, yeah, it's all over, folks. And when I say it, I mean spring. So anyway, thanks to our YouTube viewers. You may not have seen our shorts. Thanks to all of our new viewers, subscribers, etc. Don't forget to press like, subscribe, share, etc. Check out our other content, as we do put out stuff besides space weather. 2 product reviews came out yesterday, so check those out. Also, don't forget to follow us on Twitter if you're on social media. Twitter is where most of the action happens. It's also where and exactly the same amount of censorship happens. Lots of pathetic censorship on this platform, just like Meta, just like Alphabet, and just like Apple. Full of censorship. We are also on Instagram, so check us out there, especially if you like fitness and lifestyle posts, food posts, and things like that. Daily updates on Instagram, and let's take a look at some coronagraphs since we've got CMEs happening and a flare happening as we create the video. So anyway, this is yesterday's coronagraphs from George Mason University. Pretty minor CMEs there yesterday. And let's see if we have any more frames from today. It's only 10 frames at this point. Some missing data there from the Soho Lasco C2 and C3. So that's going to be unfortunate, although Stereo A does have some. So here is the data from Soho Lasco C2 and C3, the coronagraphs in the Soho spacecraft. And they're not really showing anything, so let's switch to Stereo A. And we show this diagram just to show folks where things are. And part of the reason why there was limited information about the CMEs that struck yesterday is because we don't have any spacecraft. We don't have the Solar Orbiter, we don't have Bepi Colombo or Parker Solar Probe on this side of the sun. So there was nothing else besides our channel to forecast those CMEs. Anyway, Stereo A is in the process of overtaking Earth and vice versa. Same with Stereo B, a very small angle in between those spacecraft and planet Earth. Here's Stereo A on the left, and you'll see a CME happening here. So there's that CME coming out of the northwestern limb. That is a significant one. It does not appear to have any chance of having any earthly directed components. I suppose it is theoretically possible. Let's take a look at some additional coronagraphs here. We'll show our custom coronagraphs after that plays through one more time. Keep in mind, those are not time synced. There's about 6 hours of missing data on the Soho spacecraft. Anyway, here are our custom coronagraph videos. Here's a 24-hour video featuring SDO 193 angstroms, And you see at the end there, the coronagraphs stop moving. That's the about 5 or 6 hours of missing data from the SOHO. So it's a CME off there to the northwestern direction, not likely to be earthly directed. Let's move in a little bit closer here. You see that plasma there releasing at the end of the video in the upper right. And here's a full view, just 193 angstroms. And there it goes. And let's move to filaments. So filaments are next on the agenda. And by the way, did you know that our channel has an agenda? Yeah, facts. Facts and the truth. We are approaching science from a good faith perspective. We're interested in how things really work. So that's a reason to write a paper explaining the solar sunspot cycles. It's one of those things that you just stumble upon accidentally. Whoops, I think I figured out the mechanism that underlies the solar sunspot cycles. No big deal. It's just the most important science paper in hundreds of years. Nothing to worry about, folks. Nothing to see here. So this is the filament view, and that's hydrogen alpha from the ground-based El Teide Spain telescope. And there are still a ton of large filaments on the Earth-facing portion of the solar disk. By the way, if you want to name filaments after living people, make sure you join us over at Twitter and follow the hashtag #NameThatFilament. So this is a great wavelength to show them from SDO. You can see a huge prominence up there in the northeast, a huge prominence in the southeast there. You can see the Cornell West filament has gotten extremely unstable, and it's starting to become part of a southern solar polar vortex type situation. And of course this filament here launching, and of course filaments, filaments, and filaments all over the Earth-facing portion of the solar disk. Likelihood of coronal mass ejections remains 100%, and likelihood of large flares also very high. So those are some facts. And let's take a look at the last couple of hours here, since we've got a CME happening, as well as a solar flare. So let's see where the flare's coming from. So let's see. The flare came from this setting group down here, which is what I just stated was the most likely place to see a large flare. You think that's a coincidence, folks? That's called immersing yourself in the data and understanding the correlations, even if you don't understand the causation. So that's an important thing to understand in science, folks. Correlation does not necessarily mean causation. And let's move on to our bonus features, namely satellite charging hazards. We ain't got none. It's clear sailing. No surface or internal charging hazards for satellites at the moment. That's a good thing for those of you who are looking for things like weather satellite data. And there's some interesting weather stuff going on, which we'll get to after our bonus features. Electron flux here moving up back toward warning levels. That's the past 3 days as measured using radiography by the GOES 16 and GOES 18 from their geosynchronous near equatorial orbits. They measure the F-layer of the ionosphere for the electron flux. There's the 1-year graph to put all of that in context. Moderate to high levels of electron flux at the moment. There is the forecast model. NOAA expecting a little downtick in the electron flux. No argument from me there. And let's take a look at the layer where it's measured and the vibrational frequency therein. The F-layer of the ionosphere. The F-layer of the ionosphere. Feel free to pause the video on this frame if you're not familiar with the data depicted. So there is the previous day. Quite a lot of low-frequency anomalies here happening in the ionosphere. That is fairly common for even glancing below CME impacts. Because keep in mind, a CME can move past the Earth and affect the magnetic fields without even really being a direct impact. So, and keep in mind, the solar wind is measured at Lagrangian point 1. We don't measure it from inside the Earth system because it can't be measured inside the Earth system. You've got to be like 1,000,000 miles away with your spacecraft orbiting Lagrange 1 to measure the solar wind. This is the vibrational frequency of the F layer of the ionosphere. Again, lots of low frequency anomalies happening here, including in the northern hemisphere, despite summer approaching. So we'll also show the anomalygram, and you can see a lot of red there. Those are those low frequency anomalies that I talked about. And there are sufficient numbers of those for it to be obvious in the raw vibrational data. This is anomaly in megahertz from a 30-day median. So I won't try to explain that. That is just anomaly in megahertz from a 30-day median. High frequency anomaly depicted in blue. Low frequency anomaly depicted in red. And the ionosphere did indeed puff up a bit as a result of the CME impacts. They were minor. They were forecasted. There's the latest image, 11 o'clock Universal Time ionogram and 11:15 Universal Time anomalygram. We also like to show the total electron content because everybody who's frightened of a pole flip doesn't understand the physics, apparently. So we like to show the total electron content because there would be all kinds of anomalies showing up here if the poles were actually flipping. We don't think they are. Feel free to pause the video on this frame if you're not familiar with distances in miles. Here is the total electron content. This will show you the most likely places for GPS errors, and we are seeing some significant high electron content anomalies around the Southern Ocean once again. So south of the African continent there, the Indian and Atlantic Oceans there, showing some high electron content anomalies in the Southern Hemisphere. Not big anomalies, though. Keep in mind, anomalies are more consistent with CME and coronal hole impacts, so not really too much of a surprise there. Those are the most likely places to see GPS errors. That's the free electrons from about 12,500 miles of altitude down to your handset. Here's the anomaly from the 10-day average for just North America for total electron content. It depicts the free electrons in the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. And that inner portion of the outer Van Allen belt, that's about 12,500 miles of altitude where your GPS satellite is located. So like yesterday, we're seeing some electron content anomalies there. They're pretty minor, but they're over places like Central America, Mexico, and the Caribbean. They are minor. We'll close out the space weather section of this video with the latest intensity gram right there and the latest magnetogram from SDO. So here's a sunspot group that doesn't have a name, and here's a sunspot group that doesn't have a name. That's at least two more name groups as we approach 200 sunspots. Many of these sunspots are magnetically complex. If you look at this group down here, it is beta gamma delta class. And so, I mean, it's just called immersing yourself in the data for accurate forecasting, folks. Accurate forecasts and an understanding of the actual physics. So anyway, there's your rock back. This sunspot that doesn't have a name yet, that is beta gamma class. I won't say beta gamma delta. This group here is also beta gamma. It's barely beta gamma delta class. Very high propensity for large flares. And let's move on to meteorology. So here's our meteorology segment, and we're looking at a bunch of warm water around the equatorial Atlantic Ocean because there is a tropical system that's formed here. I forecasted that it's going to be weak and it's going to be a dud because it's surrounded by a bunch of dust. There's an anticyclone just to its north, which is going to create a bunch of wind shear. You can see that depicted right here. There's this upper level high pressure zone rotating counterclockwise, and it is huge. So that's going to create wind shear to the north of this thing, and I don't think it's going to strengthen very much, although there is a lot of warm water there. So this is something that you're going to hear all about on the internet in the coming days. I won't spend too much time talking about it, but we will consider showing some forecasts here as it gets closer to the Caribbean. Wow, look at the warm water south of Mexico. Nearly 90-degree water there. This water over here ahead of this storm is like 83 degrees. So there's a lot of convection available there, but there's also a lot of forces that are working against that system, not the least of which we showed yesterday is the Saharan dust. So the combination of the Saharan dust and that anticyclone do not look good for that becoming a legit hurricane. Anyway, I think it is a tropical storm now. But yeah, we'll cover some forecasts in particular of that as it gets closer to the Caribbean. Anyway, here are the surface winds of the eastern world. Multiple strong systems here. 2 powerful lows here in the West Pacific. Powerful lows here around New Zealand and Australia. A powerful anticyclone here off of the west coast of Australia. There you can see a great example of a southern hemisphere anticyclone rotating counterclockwise as they do south of the equator. That area likely accompanied by clear skies. Anyway, here are the jet streams for this side of the planet. Ta-da! Jet stream blowing backwards over the Indian Ocean. Here are the jet streams of the Western world, and incoherent jet streams returning to the North American region. Look at these huge bends over Western Canada, also the Eastern U.S. That will help to feature some weird weather. Once again, folks, incoherent jet streams over the U.S. It's going to cause people to believe idiotic stuff, like mankind is able to control the weather. Truly a ridiculous idea by people with small minds and small thinking who don't understand physics. They don't understand physics. That's why they think mankind can control everything. They think mankind can control everything from the orbit of the moon to planetary orbits to turning on CERN causes sunspots. It's pretty ridiculous. Pretty pathetic. See our community posts about some of the pathetic nonsense about weather modification. So here are the surface winds for this side of the planet. And again, there's a lot of wind shear that's not going to help that thing hold together. I think it's going to be a weak dud. Let us know in the comments what you think. Here are the surface winds of the central world. And these are the jet streams. Moving right along here to our, I'm not going to show a snow map. Let's actually take a look at, we're going to show pressure. And we'll zoom way in on this tropical system down here. Not very low yet. Wind speeds are 37 miles an hour. Not very exciting. Not very exciting, folks. Again, a lot of factors working against that tropical system. There's the wind map for the whole planet. And it's looking like a cold winter is coming to the southern hemisphere. Anyway, we can not look at global cryosphere watch. I'm not worried about that. And I'm also not worried about the Antarctican gravimetric mass balance. What I am concerned with is showing you clouds and fog over the Americas. So let's do that next. Give me a minute here. We apologize for this delay in the action. Here's clouds and fog over the Americas. It's the 3.9 micrometer infrared radiation map. It shows clouds and fog at night. If you're concerned if you'll be able to see the aurora or not the next time we have a real geomagnetic storm, try this map. Or you could always go outside and see if you can see stars. That works too. We've got some cloudy skies over the mid-Atlantic states. Again, an incoherent jet stream is all over the place. The jet stream is like, it's going like this, and it's coming down like this, and it's very bizarre jet stream. And let's take a look at weather warnings. So here is your weather.gov map. And by the way, those are hard freeze warnings for a lot of Nevada, Oregon, Northern California. Freeze watches, freeze warning, frost advisories, and so on. Summer, it's coming in with the accompanying 2 feet of snow in parts of Canada. Those are your weather alerts. Let's take a look at some forecasts here from Tropical Tidbits. So let's just show, we're going to show the pressure and precipitation forecast. So there is pressure and precipitation for the next 72 hours based on a GFS model. And parts of the Albertan Rockies there will kick off summer with a fresh 2 feet of snow. Some extreme weather here coming to the central U.S. as well. You can see South Dakota, Nebraska, Colorado, Kansas, Oklahoma, and Texas expecting some severe weather. That's your 72-hour GFS pressure and precipitation forecast from tropicaltidbits.com. Next, looking at lightning. There was certainly some significant... Actually, let's look at one more forecast here. I forgot to do temperature anomaly, since we've got some crazy cold temperatures to kick off summer, especially in the western states. Check it out. There's your temperature anomaly forecast. Wild temperature swings in Texas and very, very cold temperatures here in the western. Look at California, even LA. It'll be 16 degrees Celsius below normal. That's your 72-hour GFS temperature anomaly forecast in degrees Celsius. Really, really hot in eastern Canada and really, really cold in western Canada. Dag. Those are some wild variations. Anyway, again, here's lightning. Let's take a look at a real-time lightning map. Lots of lightning around Florida especially. And we've changed the lightning map here. We brought up the day-night because, well, tomorrow is the solstice, which means the sun will be returning to the southern hemisphere. Today, tomorrow, and Thursday will be the 3 brightest days of the year for the northern hemisphere. And of course, the solstice coming to this part of the planet is coming just about an hour before noontime. So like 2 hours before true noon for the eastern U.S. It'll be like a true solstice for us. Anyway, there's your real-time lightning map. I don't think we have any terrestrial. We may have some terrestrial strikes. Gainesville. There is certainly an active system there. Thunder rolling in there. Also at Ocala. If you enjoy the content, press like, subscribe, and share. Don't forget to visit our links, as we've got all kinds of additional content besides these videos. We created our own massive web ring for people like you because, well, you've got access to a bunch of crap on the internet. The social media situation is truly pathetic, so we built our own web ring for this reason. So visit our links and help support the channel that way. Help us out with clicks if you're unwilling to open your cobweb-encrusted wallet. Highly recommend you become a member of the Smash team. There's even a bronze level that costs you nothing per month, $0 per month. You get email alerts about certain things, so highly recommended. Thanks to the Smash team, especially Gold and Silver Smash team members, they've increased the probability these videos will continue to exist, remain publicly visible, and free for all to view. Smashomash.com/Smash Team, our official subscription services site. Built to provide additional content similar to Patreon, just better. We'll close out this video with Doppler U.S. lower 48 weather. And we'll show the full 50 states here briefly. There is the situation depicting vertical motion in the air column by ground-based Doppler systems. Here is a lower 48. Here is clouds and fog over the lower 48. And here is the water vapor map. So, I mean, this situation is interesting in that you've got a huge mass of dry air here. So, once again, this is sort of the feature that is in charge of the situation. This cold air blowing down from Canada wants to get constrained into this more moist air because it is less massive, so it wants to bounce off of this. Also, we've got this strong impulse going south into the Gulf. We've got this impulse coming up to the north. I mean, all kinds of funky forces here. It is all jet stream driven. Jet stream driven. Not chemtrails, not HAARP, not weather modification of any kind. If you think mankind is able to control the weather, you seriously have to take physics. Please take physics 1 and 2 because it's just ridiculous. Large-scale weather patterns are not controlled by humans. It's truly an idiotic idea. Anyway, here's your recap. U.S. Doppler radar. Strong storms moving across northern Florida. Here is clouds and fog. Those are pretty compact systems. They are the result of rapid cloud nucleation, as you can see there. And they should be making their way across rather promptly because they have an impulse behind them too. This dry mass of air is going to push them right to the east. And that is where we will close things out. Congratulations on realizing the channel exists, and welcome to the end. It's the end, folks. It's all over. And we'll see you tomorrow for multiple videos. Once again, thanks for tuning into the Smash News Network, least busted name in news. Since the end is here, I'm going back to the bunker. Bye. Whoa.